All right, we're going to talk about converting numbers between different bases. In other words, base 2, base 10, that kind of stuff. What's decimal? Base 10. We're just used to it, that's all. It's actually, it's not one of the harder ones, but it's definitely not the easiest one out there. But we're just used to it. So, all right. All right, so before we start, are all these numbers identical?
No.
Why not?
The last one says 259.
This one's missing a 0 at the end. But do zeros at the beginning matter? No. Zeros at the beginning do not matter. Okay, and I think this is it. Perfect timing. We're delaying the longest we could.
Thank you.
All right, so these numbers are all the same except for this guy because this one's missing a 0 at the end. But the zeros at the beginning don't matter. Okay? And the reason I came up with this presentation, by the way, is for IPv6, which is in hexadecimal, which the book doesn't even mention. So you kind of need to know how the whole system works. Okay? So no, that one's not because of the 0. Okay? I made all these slides myself, so they're kind of weird. It's okay. This is decimal. Look familiar to everybody? Goes 0 through 9. Then we change it to a 0, increment the next number through 9. Change it to a 0, increment the next number. 0, you know, are we okay with that? See how that works? We can continue. 99 to 100 and so on and so forth. Nothing new there. Everybody got that? You sure? Because that's all the other ones are. I mean, it's that easy. But we just use less numbers. Or more numbers. Depending on which one. Okay? So, how about this? Alright? You all agree that this 10 to the 0 is 1? And 10 to the 1 is 10? 10 to the 2 is 100? And so on and so forth? Yes? Okay? So 241 is 2 of the 10 to the 2's, 4 of the 10 to the 1's, and 1 10 to the 0. So far so good? I mean, that's what we've done. Did they teach it this way? I seem to remember them teaching it this way in high school at one point or something. Or elementary school or kindergarten or something.
Yeah, they break it down, you know, the 200s, and then you get your
All right. So they did it some, I just can't remember where. But, you know, I've determined that I'm getting too old. I can't remember this stuff. But, okay, so we're all okay on this so far. Okay? So really nothing new yet. It's just what we've been doing. Okay, powers of 10. Now let's go binary. This is the decimal column. This is the binary column. Okay? 0, 0, 1, 1. We're at our maximum number, so we increment, change that one to 0. Increment the next guy. We're at our maximum number, increment the next number, change it to 0, so on and so forth. In decimal, we just went 0 through 9, then incremented. 0 through 9, incremented, 0 through 9. Well, in binary, we only have two numbers. So we go 0 through 1, increment. 0 through 1, increment. So 0 and 1, increment that guy. 0 and 1, increment that guy. 0 and 1, increment that guy. 0 and 1, you know, so on and so forth. Okay with that? Yeah. It's actually easier, but it's one of those deals we just don't see it all the time. Okay?
So 10 would be 1011?
No. 1010. Because we would increment the 0 to a 1 and change that back to a 0. Just like 99, increment the 1, change the 9s to a 0. So 10 would be 1010. Everybody got that?
So basically, anytime you have 10, 20, whatever, it's going to be 1, 0. The end's going to be a 0.
Correct. Yes. Now, up here, I got 15 and 16, so 15 is all 1s. To increment from 15, I increment the next one, change all the 1s to a 0. So that's how I got 16. 31 to 32, 31 is all 1s. To go to 32, you increment the next number, change those back to 0. It's just like 99 to 100. When you get all 9s, you increment the next one, change them all back to 0s. It does the exact same thing. It's just that we only have two numbers to work with. Okay? And these PowerPoints are already up under the content page, so when you have to do this assignment, they'll be up there to help you. Okay? So I put them up there earlier as well. So, how about this? Okay? So, just like we did with the 10s, 2 to the 0 is 1, 2 to the 1 is 2. Now, in decimal, 10 to the 1 was 10. Remember that? But this one, it's, 2 to the 1. So 2 times 1 is 2. Then 2 to the 2 is 4. That's 2 times 2. Are you with me? So 10 to the 2, or 10 squared, was 100 because it was 10 times 10. Okay? Everybody got that? 10 to the cubed was 1,000 because it was 10 times 10 times 10. And here, 2 to the third power is 2 times 2 times 2. 2 to the fourth is 2 times 2 times 2 times 2. So the numbers are incrementing by 2 every time. That's all they're doing. Starts with 1, 2, 4, 8. You know, they're basically doubling. That's all they're doing. In the tens, if I go back a couple slides real quick, we're just adding a 0. We're adding a power of 10 each time. Okay, in the binary, we're adding a power of 2. We're just doubling it. Everybody see that? So 2 to the 8th is 256. What would 2 to the 9th be?
512.
512. 2 to the 10th?
1024.
1024. I mean, you could go there. 2048, 4096. You know, you can just keep doubling it. So it's really, if you can understand the theory, it's quite simple to do. Okay? So 241 in this one. Okay, I just can't say, you know, 2 over here. But what I need to do is, okay, 2 to the 7th is 128. Okay, can 2 to the 8th fit inside of 241? No, 256 is too big. So obviously I have to go down 1. It's just like when we did 241 in decimal. Could I have taken the thousands place? No, it's too big. So I go to the hundredths place. Well, 256 is too big, so I go to the 128th, or the 2 to the 7th place. I need one of those. If you subtract them out, I didn't do the math all there, but it ends up being one of these, 1, 1, and then 1 at the end. So basically, if you had taken 241 minus 128, actually, let me do that. Fun. Then I'm about to see, so that's right. 241 minus 128, okay? I'm going to subtract them. So this becomes a 3. That's a 3, and this becomes a 1, a 1. I got 113 left over. Okay? So obviously, it's still too big. So that's why I can only have one of them. 64. So I go minus 64. So this is going to be kind of, wait, that goes to 0. That kind of 10. That'll be a 13th. That's what, 9? 94. Is that right? 49? 49, isn't it? Yeah, should be 49. Okay. So I need one of those. Then I have 49 left over. So obviously I can put a 32 in there. Got 17 left over. Okay? So 17, I can obviously put a 16, I got 1 left over. So I can put a 1. So 0, 1, 1, 1, 1, 0, 0, 0, 1 is 241. Okay. Easy enough
You
to do?
pretty much have to be really good at the square roots, but can't think of what it's called now. Powers, yeah.
Yes. And you just have, and the deal is if you use this a lot, you will sooner or later get it.
Okay.
Go ahead.
I'm sorry. So like that, to the third power,
Right.
that wouldn't fit into your subtraction, so
Right.
you put a 0 there, right?
Correct.
That way-
Because when I did this one, I had 17.
you
So I
can
fit
put
a
one
16
there.
in there, one of the 16s, so I have 1 left over.
Okay, 8 wouldn't go into 1, 4, but we can go down there to the 0, which is 1. And so you just put zeros in those places.
Correct, yes.
And that'll
It's
get-
kind of like, if I was telling you the number of, 4,280,000, there was some spots where you just put zeros there. So yeah, same thing. All right, so far so good? All right. Octal, not even mentioned in your book. It's a good thing to know.
Okay.
Now, instead of working with 10 numbers or 2 numbers, now we work with 7 numbers. But to do this, we break it into groups of 3. Okay? Just remember. Again, this is not going to be on your test, maybe. But it's but it is going to be on your homework. Okay? Now, I broke it into groups of 3. Y'all see these are groups of 3 here? Obviously, 0's a tough one. Now, you notice all these I convert them to binary. Binary to octal is easy. Binary to hex is easy. Yeah. But the other way around is not quite as easy. So, 0 there. 1 the same way, just like, then 2, just like binary, then 3, 4. You get up to 7, and that's as high as we can go. 7 is like a 9. So what do we do when we get to a 7? Convert it to a 0, increment the next number. Just like we did in 9 to 10. we get to the maximum number, which converts to a 0, increment the next number. So we go 11, 10, 11, so on and so forth. Okay? So in octal, you can't say 8 and 9. There are no such thing as 8 and 9, but there's a 7, 10, and 11. It's kind of weird, but the problem is we keep thinking back to decimal, and it's not going to work. Okay? Now, when I did this, when I went to 10 over here, really I just incremented the next one, changed all the zeros. Then I brought the 1 down there. But you have to break it into 3s, that way it fits. Because if you notice with 3s, 0 to 7 all fit in the area of 3. If I gave you 3 places, the maximum number of choices you could come up with is 7. So if you look at these first 7 numbers, that's every possible combinations of zeros and ones we could have. There's no other way to do it. So that's why octal works in 3s. Okay? So up here, I have 0, 0, 1, 1, 1, 0, 1, 1, 1. So we do it in groups of 3. 0, 0, 1 is 1. Easy enough. 1, 1, 0 is 6. 1, 1, 1 is 7. So we get 167 in octal. See that? So 1, 1, 1, 0, 0, 0, 0, 0, 1. So the 1, 1, 1 is a 7. The 0, 0, 0 is a 0. And the 1 is a 1. 701. See how that works? You've got to break it into groups of 3. Okay, I learned this way back when I was working on my bachelor's degree. I took some class, whatever it was, I don't remember now. And he had us do this, and it was one of the coolest things I remember on my bachelor's degree because it makes you think. Okay, so everybody see how to do it? Following along?
So basically, once you convert 0 to 7, then all you have to do is, and what each one is in binary, it's basically the same thing. Well,
Right. Well, okay, how about this last guy? 1011, how's that 13?
101 is,
Because it's 0, 0, 1, 0, 1, 1. If you break it
0,
down,
0, 1, 0, 1, 1. You break it in groups of 3s from the right. So 0, 1, 1
Okay.
is 3. And we got a 1 left over. Isn't that the same number right there? So 0, 0, 1 is the same as a 1, so that's how we get 13.
So since you have to break it into groups of 3, then you top out at 777.
Correct.
Okay.
Yes. But you could always, go to another group. You could have, groups of 3, groups of 3, groups of 3, groups of 3. You could have a whole bunch of groups of 3, and you have a bunch of 7s. So, everybody see how that works? Just
you basically start reading
From
right
the-
to left instead of left to right.
right. We start with the right. It's just like in English. We always start our numbers to the right. If I was to write, that big old long number like we did at the beginning with a whole bunch of zeros, you wouldn't want me to start, okay, the first 3 is the pennies, or the first 2 is the penny. It wouldn't work. You always go from the right with numbers. Always go from the right. So everybody see it? You see how we got the 554? Go from the right. Now I showed it to you broken apart, but if I showed it to you not broken apart and ask you to convert this binary to octal, you just break it into 1, 0, 0, 0, 1, 0, 1, 0, 1, and you break each one out.
0, 1, 0 is 2.
Where's 0? Yes? Oh, I got an error on mine. Oh, good catch. Whoops, sorry. Good point. That's an error on my part. How the hell did I miss that? That's good. I fixed the spelling on the other one earlier today, too. Okay, he's right. It's 524, not 554. Damn it. Oh, well. All right. Now to go to octal to decimal. See, the easiest way to do this, by the way, is convert them all to binary. And binary decimal is easy. But if you wanted to go octal to decimal, 756, just like we did, we got 8 to the 0 place, 8 to the 1 place, 8 to the 2 place. Put a 756. 8 squared is 64. 8 to the first is 8. 8 to 0 is 1. So 6 times 1, 5 times 8, 7 times 64. Add them all together, you get 494. See that? Again, you got the slides to work with on the homework, so make it easier. Now what about 2701 octal in decimal? Alright, that's a bigger number. Well, I did it for you. So instead of, we have 8 to the 0, 8 to the 1, 8 to the 2, 8 to the 3. So even though 8 to the 1's a 0, we still use it. So it ends up being, 8 to the third power is 512. So it's 2 times 512 plus 7 times 64. That's this guy. Plus 0 times 8 plus 1 times 1. So we end up getting these, and it's 1473. Everybody see that? All right, hexadecimal. Here's the whole reason for doing this. IPv6 uses hexadecimal. Okay? Now, just like we did in Octal, we can go to 7. But now instead of stopping at 7, we can actually stop at 16. Okay? So we continue on. So that column is a continuation of this column, in case you're wondering. So we get to 7, then we go to 8, then we go to 9, then we go to A. So A is really 10. See that? Then 11, 12, 13, 14, 15. So 0 through 15 is 16 numbers. So 0 through F is 15 numbers. To do this one, you break it in groups of 4. Okay? And in groups of 4, if you look in these two columns, every possible combination of 0 and 1 is represented there. And that's 0 through F. Okay? Then when you break it into 4s, it's quite simple. So 1100. What is 1100? 1100 is a C. So this first number is a C. 0101 is there. It's a 5. So we have C5, and all 1s is F. So this binary number of 111101011100 is FC5.
F5C.
Yeah, F5C. That's what I meant to say.
That
Yeah. All right. Got it? Everything? What do you think? Kind of following along with what I'm doing? It's very different. It's not in your book, but, it's not very hard. That's why I made these awesome slides, except there's one typo in them so far.
Isn't the ASCII code based off the hexadecimal?
Hexadecimal does convert to ASCII very easily, yes. Yes, it does. Not totally, but yes, it does. I cover that in computer security. So, all right, is everybody okay on this? So how do I get 14?
1 and 4.
So if I break it into groups of 4, I got 0100, and that is 0100 is a 4. Then I have a 1. So I have 0001, which is a 1. So I get 14. Everybody see that? All right. So I told you the number 10. What's 10 in hex?
1010.
In hex, though. What's 10 in hex?
A.
A. Exactly. In one of my classes, I tell them to scan a network. I said, in hex, the network is, whatever. I give them some weird number, but it's not what they think. Because 10 in hex is not 10 in hex, so it's kind of weird. All right, now, hexadecimal. So 3b2, we have 3 times 16 to the second power, then b times 16 to the first power. Well, what the heck is b? B is 11. See that? Again, I'm showing you the binary here, but b is 11. Because that is 11. Okay? So 11 times 16 to the 1 and 2 times 16 to the 0. So you get 3 times 256, 11 times 16, and then 2 times 1. So what is 5b48 in decimal? Well, just bring in 16 to the third power. So 16 to the third power is just 16 times 16, which is 256, times 16, which is 40 times 6. And you end up with 23368 in decimal. Okay? So other than the one typo, you should be able to follow these slides? Y'all know what the typo was? All right. Yep. All right. Could you do this? With some work? All right. Before I end these slides, I want to show you something else that would rather you not, but if you want to check your work, you can do this. Bring up handy dandy calculator. And I did View Scientific or View Programmer if you're doing it in yeah. Now,
See, I remember that.
I can go like 199 in decimal. I want to know what it is in, oh, hold on, view programmer. So it's 199. In binary is 11000111, and octal is that, and hex is that. So you can check your work, but just kind of figure out how to do it. Again, you don't have to know how to do this.
I wonder why we're the only pretty much only country so using decimal.
Because we're a bunch of idiots. Well, actually, the other countries still use decimal, but they don't use it for pounds and and the mileage and all that. They use the whatever the metric system. So you can check your work with this. Are we okay with that?
Yeah.
I'd rather you not just bring up the calculator and do them all in 2 seconds. The whole point is, I would never know. That's what I'm saying. The homework, you should get 100. But the whole point is I want you to know how to do it, because when we get into the subnetting area, it'll be kind of important how to do the decimal, the binary, that kind of stuff. Okay? All right. I think that's the end of this. Well, that's the end of this one.